Okay, class, picking up where we left off at. We're on problem 49, and first of all, we need to do what's inside the parentheses first. So what I'm going to do here, I'm going to scroll down a little bit to give me some room here. So for 49, I would do 12 divided by 6 is 2. And then x to the 4th over x to the 8th. We know if we subtract those exponents, that'll give us x to the negative 4. And then y to the 7th divided by y to the 3rd will give us y to the 4th. Now, we would take this whole parenthesis to the 3rd power. So now, we would add 2 to the 3rd power, which is 8. And then x to the negative 4 to the 3rd would be x to the negative 12. And y to the 4th to the 3rd is y to the 12th. So now, our final answer would be 8y to the 12th all over x to the 12th. Because we know that goes to the denominator. Now we go here to problem 50. Now, if we look here in this parenthesis, there's nothing we could do in this parenthesis except for we could actually make this parenthesis to be 4y to the 4th all over x squared. That's basically all we could do with this parenthesis. Now, we have negative 3 on the outside. So that's to the negative 3 power. So if we get rid of this negative, we would just have to take the reciprocal of what's inside this parenthesis. So now we can take everything to the 3rd power. This will give us x to the 6th. 4 to the 3rd power is 64. And y to the 4th to the 3rd is y to the 12th. And that is the final answer for 50. Now we want to go on to 51. If you notice, both of these parentheses are taken to the exponent. So I'm going to write their answer down here. So 2 to the 2nd power will give us 4. A to the 3rd to the 2nd is A to the 6th. B to the 4th to the 2nd is B to the 8th. Then we would do the next parenthesis. 3 to the 3rd is 27. A to the 5th to the 3rd is A to the 15th. And B to the 1st to the 3rd is B to the 3rd. Now 4 times 27 is 108. A to the 6th times A to the 15th is A to the 21st. B to the 8th times B to the 3rd is B to the 11th. And that is your final answer for problem 51. Now, if we go here, we look here at 52. Now 52 is a little different only because we have negative exponents on the outside. Now what we could do is this here. We can multiply the exponents. We could take the negative power. So we could take these negative powers here. So we could take, well, first of all, let's do what's in parentheses first. So we have 4 over p squared. Then this would be to the negative 2 power. And then we would have, this would still be just 2p squared. Well, we could do this. If this is negative, we'll make this 1 over 2p squared to the 3rd power to make that exponent positive. Now, since this exponent is negative, to make it positive, it'll be p squared over 4. And that'll be squared times 1 to the 3rd power is 1, 2 to the 3rd is 8, p squared to the 3rd is p to the 6th. Now, we would take this to the power of 2. We have p to the 4th all over 16 times 1 over 8p to the 6th. So p to the 4th times 1, we know will give us p to the 4th. 16 times 8 will give us 128. And then we will have p to the 6th. Now p to the 4th divided by p to the 6th, we know that's going to leave a p to the 2nd in our denominator. So it'll be 128 p to the 2nd in our denominator. And since the p to the 4th is gone from our numerator, this will leave it as 1. So it'll be 1 over 128 p to the 2nd power. Okay, now, for problem 53. Now, the first thing I would do here is do what's inside the parentheses first. we know this x to the negative 4 will go down to our denominator. Let me see if I have a little bit more room here. Yes. So then we would do this. We would have, in our numerator, we have y squared. And our denominator, we would have x to the 4th times x to the 4th times, well, this y to the negative 3, we know we can move it up top to be y to the 3rd. Okay, so now, and this is all taken to the negative 2 power. So now, since this is taken to the negative 2 power, well, first, let's combine these. This will give us y to the 5th all over x to the 8th. That's all taken to the negative 2 power. So now, to make this a positive, we would take the reciprocal. It would be x to the 8th over y to the 5th. And then this is taken to the 2nd power. X to the 8th to the 2nd will give us x to the 16th. And y to the 5th to the 2nd will be y to the 10th. And that is the final answer for problem 53. Now, problem 54. What we could do with problem 54 is this here. 54, we would square these parentheses and then multiply them and then divide. So, if you all watch closely, let's square this first. 3 squared is 9. X to the 1st to the 2nd is x squared. Y to the 4th to the 2nd is y to the 8th. And that would take care of this exponent here. Okay, next, we will have 9 squared, which is 81. X to the 4th to the 2nd is x to the 8th. And y to the 1st to the 2nd is y squared. Now this will be all over 3 to the 3rd is 27. X to the 1st to the 3rd is x to the 3rd. And y to the 1st to the 3rd is y to the 3rd. So now we multiply. 9 times 81 will give us 729. X to the 2nd times x to the 8th is x to the 10th. And y to the 8th times y to the 2nd is y to the 10th. And this is all over 27. And then this will be x to the 3rd, y to the 3rd. Now, 72 divided by 27, that goes in evenly. So this will leave us 27. 729 divided by 27 is 27. X to the 10th divided by x to the 3rd is x to the 7th. And y to the 10th divided by y to the 3rd is y to the 7th. So that takes care of problem 54. Okay, class, for problem number 55, I tried to erase, but it wouldn't work out that well. So we would use this blank sheet here. So we would take this here. It says use division or synthetic division to solve this problem here. So what I would do is I'm going to use synthetic division. We look here at the denominator. We have x minus 5. So we know we do our divisor here. And we'll take the opposite of negative 5, which is positive 5. Now we would list all of the coefficients. We have 4, negative 22, and 10. So we'll draw a line here. We leave some space down here. So we will be able to write numbers. And we'll draw this line in between the last two numbers here. So we'll bring down our 4. 5 times 4 is 20. Negative 22 plus 20 is negative 2. 5 times negative 2 is negative 10. And we have no remainder. Now we look here at our highest exponent. We will make our final answer have, its exponent will have 1 less than the exponent here. So this would be 4x minus 2. So this would be your answer for problem 55. Now, we're going to go over here and look at problem 56. Problem 56, you notice here we have the same thing we had for this previous problem here. But we have a negative 3, so we'll make it positive 3. Then we would do the coefficients here. We have 2, 3, negative 1, and also 1. So we draw a line here. We'll bring down 2. 3 times 2 is 6. 3 plus 6 is 9. 3 times 9 is 27. Negative 1 plus 27 is 26. And 3 times 26 would give us 78. And 78 and 1 would give us 79. So we know our remainder is 79. So we would go one exponent lower than 3. So we had 2x squared plus 9x plus 26 plus 79 over what we divided by, which would be x minus 3. And this is our final answer. Now we come to this last problem here. Now if you notice, this last problem is different because we had 2x plus 5 in our denominator. So we're going to use long division here. So we had 2x plus 5, and it will go into 4x squared plus 2x minus 23. So we say 2x goes into 4x squared. We know it will go in 2x times. 2x times 2x is 4x squared. 2x times 5 will give us a positive 10x. And we have to change the sign of both of these values. 4x squared simplify out. 2x minus 10x will give us a negative 8x and minus 23. 2x goes into negative 8x a negative 4 times. Negative 4 times 2x is negative 8x, and negative 4 times 5 is a negative 20. We'll change the sign of both of these values here. The negative 8x and 8x will simplify out to 0. Negative 23 plus 20 will give us negative 3. So our final answer here would be 2x minus 4 minus 3 over 2x plus 5. And this is it.